good on camera.
No, I don't. You're very kind. All right, so now we're going to add one more chicken to the flock. Or excuse me, I should take that back. We're going to add one more baby bird to the flock. I don't know what it is yet. I don't know if it's a girl or a boy. But what I want to do is I want to analyze what I am likely to have. I want to analyze what I am likely to have. So here's flock number 2. Here are my birds, Bertha and Nancy. Bertha and Nancy, let's figure out what we've got. All right. Okay. So flock number 2, we now have 2 birds. Now I know we're working up to 4 birds, but this would apply to anybody's flock who only buys 2 birds. Or if they buy 4 and 2 die or something like that along those lines. So assuming there's not some kind of a weird condition on who dies more frequently. But we're going to buy 2 birds. Let's figure out the distribution of the genders. Okay, same distribution, X and P of X. And I'm still interested because I want eggs in the number of girls. How many girls can I have?
0.
None.
1 and 2.
1 or 2. Beautiful. 0, 1, or 2. Pick one of those outcomes and tell me how likely it is. Pick one of those outcomes and tell me how likely it is. For example, what is the chance of not getting any girls? Say that again.
0.2.
Why 0.2?
If it's double 0.1, if my models for 1.
But if it's double 0.1, that means 0.1 plus 0.1, right?
Yes.
That means, let's think about that. That means it's more likely to get 2 roosters than it is to get 1 rooster. Does that make sense?
You have to multiply on that.
Multiplying will make it smaller.
Yeah.
Does that make sense?
Yeah, 0.9 times 0.9.
I like this discussion. So we got 2 votes. We got 0.1 plus 0.1, or 0.1 times 0.1.
That kind of follows the distribution thing.
Why does that follow the distribution thing?
You have 2 chickens now, so you have the 0.1 chance and another 0.1 chance. And
Did you hear the word "and" that was just in there? In order for us to have 2 roosters, that means Bertha has to be a chicken, excuse me, a rooster, and Nancy has to be a rooster, yes? Bertha and Nancy both have to be roosters. In order to do 0.1 plus 0.1, that would be Bertha is a rooster or Nancy is a rooster. I don't want or, I want them both to be roosters. So it has to be multiplied because that's what "and" means. We learned that in your last project. Or from your first project means we add, and from your second means we multiply. So yeah. The chance of them both being roosters is 0.1 times 0.1, which is 1 in 100. And that makes sense. It should be hard to get 2 roosters. If only 10% of them are roosters, it's only 10% likely your first one's going to be a rooster. And then you have to have the unfortunate luck of getting another rooster, which only happens 10% of the time. So it's 10% of 10%. If you want to use an old mathematical term, of means multiply as well. 10% of 10% is 1%. That's what that is. So if you bought 2 birds and got 2 roosters, you should be pissed. Because that shouldn't happen that often. It should happen 1 in 100 times you send Max into the store to buy 2 birds. It should happen 1 in 100. So roughly out of 200 birds bought 2 at a time, 1 of those pairs should be both boys. Richie, I think you were answering this one for us, weren't you? I thought I heard you saying 0.9 squared.
Yeah.
Yeah, isn't that the answer to how likely it is to get 2 girls? This is going to be 0.9 squared, yeah? And now the reasoning is parallel to the reasoning for the 2 roosters. First, you have to get Bertha to be a girl, which is only going to happen 90% of the time. And then you've got to get Nancy to be a girl, which also only happens 90% of the time, which ends up being about 81% of the time. Is that fair? Well, actually, I shouldn't say it's fair. Is it understandable? It might not seem fair right now. It might be like, I don't buy this. The fact is, it's understandable. Tie it back to what you already know. In order for them both to be girls, Bertha has to be a girl and Nancy has to be a girl. And the "and" implies multiplication. Fair enough? Notice how it went down. It's 90% likely when you buy 1 bird that your bird is a girl. It's only 81% likely if you buy 2 that they're both girls. It's going to keep going down the more birds you buy. We just saw that, right? Danielle's flock of 18, it's only a 15% chance you had all girls. It's going to keep exponentially dropping. It's never going to hit 0. There's always a chance you'll have all girls, just like there's always a chance that all the hard drives will work at COCC infinitely over time. But it just gets extraordinarily close to 0 that they're all going to work over time. Eventually something's going to fail. But that's why you have more than one of them. Fair? It's all connected, friends. Chickens, hard drives, pumpkin seeds, Gallup polls, politicians, it's all connected. That's what's so wonderful about it. I know, very heads exploding. All right, let's attack the middle. What do we do with the middle? Nathan!
There are 2 different ways you can get the 1, which means that you can either have Bertha be a girl and Nancy be a boy, or Nancy be a girl and Bertha be a boy.
Can we write what Nathan just said in numbers? Hold that thought. That was beautiful, Nathan, by the way. Awesome, we were going to say. Which is exactly what Nathan said. Now we know what the answer is. If we know this is 1% and this is 81%, that's 82%, yes? Which means the rest of it has to be the 18% that's left behind. We know kind of, but we already know about probability distributions. Now a lot of you are saying, well, why don't we just do 0.9 times 0.1? Because that way you've got a girl and a boy, yeah? But that's only 9%. Where's the other 9%?
You have to add it.
And think about what Nathan just said. He said, wait a minute. Either Bertha is the girl and Nancy is the boy, and then, or, thank you, Michelle, or Bertha is the boy and Nancy is the girl. And you have to look at both those possibilities, just like when you were rolling 2 dice. You had to look at a sum of 3 being 1 and 2 or 2 and 1. There are 2 ways for it to happen, just like here. Perfectly said, my friends, perfectly said. There's your 18% chance. 0.18. And then it balances. Then you've got all your possibilities. Roughly 4 out of 5 times, you're going to get all girls. 1 in 100 times, you're going to get both boys. And the other roughly 20% of the time, you're going to get a mixed matched. That works out to be an average of 90% birds overall. So what is the average number of girls you can expect in a flock of 2? Is it have to be 1.8? Now, there's a bunch of ways you can do that. Number 1 is go to one of our stats. L1, L2. Totally do that if you want to. I got no problem with doing that. Another way is kick it a little more old school. 0 times 0.01 disappears. 1 times 0.18 is 0.18. And 2 times 0.81 is 1.62. 1.62 plus 0.18 is 1.8 chickens per 2 birds. Another way to think about it, I think it's more direct, is realize that if from the first distribution we know that every bird contributes 0.9 of a girl, 2 birds have to contribute twice as much girl. So 0.9 times 2 becomes 1.8. Does that make sense? This is the first time that's ever happened, FYI. Usually that doesn't work out that way with our distribution. Usually we have to compute them. But this is a very special kind of distribution, of which the Gallup was an example, of which the pumpkin seeds were an example, of which the hard drives were an example. I didn't talk about them as special cases. But that's what's going on here. The average number of girls is 1.4 girls per 2 birds. Is anybody crunching the numbers on their machines using one of our stats, L1, L2? I mean, you can totally do it, and you'll get perfect agreement with the same numbers we're getting. It's going to agree perfectly. It has to. I'm getting a good idea for a quiz for you guys for next week. But I'm mentioning the 0 times 0.01 plus 1 times 0.18 plus 2 times 0.81. I'm getting a few too many blank looks. What the hell are you talking about? I think we revisit that idea again in a quiz. Should you choose to revisit that idea? Because it seems like it's gotten away from us a little bit. And it's okay! That's one of the dangers of using technology, is we become reliant on it. But I'm okay with that as long as we go back and look at it again and make sure we square that away. Fair enough? Questions? Concerns? Let's add another bird. Let's go to 3. Let's add March. I think it's March next. Yes! March. March. Marge the Orpington. Marge who lays the Easter eggs. Marge the skittish one.
Marge, the